Now we'll start with the next topic, that is concentration unit in a solution. So there are different concentration terms that we use when we make a solution. So we'll discuss that in detail in this particular module. So we shall now see the concentration units in solution. So before going into concentration unit, we should know what is a solution. So a solution is a homogeneous mixture of two or more substances. So what it is? It's a homogeneous mixture of two or more substances, and the substance word indicates components. So if I talk about a binary solution, binary means two. A binary solution will have two components. One is called solute and the other is called solvent. And solute is that component which is present in less amount, and solvent is that component which is present in more amount. So equation format, you can see solute when mixed in solvent, it is dissolved in it to make a solution, and solution is a homogeneous mixture of two substance, solute and solvent. So what is a solution? It's a homogeneous mixture of two or more substances. Now we shall see what is concentration. Now concentration of a solution is the amount of solute present in a given amount of solvent. So what are the concentration? What do we mean by concentration? It's the amount of solute. Now amount can be number of mole, mass, gram, volume, etc. So amount of solute in given amount of solvent. And generally solvent is water. It acts as universal solvent. Now what are the different methods to express concentration? Now what are the different unit to define concentration? So let's see that. The first is in terms of percentage. Now in percentage we can define concentration. Now in percentage also we have subcategory. The first percentage is percentage by mass, W by W. So you are telling the mass of solute and mass of solvent. So it's the ratio of mass of solute in the total mass of solution into 100, because percent means in total of 100. So how much is amount of solute in the given mass of the solution into 100 is mass percent. So this is mass percentage. Next is volume percent, that is mass of solute upon volume of solution into 100, that is W by V. Or by strength, volume of solute upon volume of solution into 100, V by V. This is the first term in percentage. The second term is in parts per thousand, that is PPT, or parts per million, PPM, and parts per billion, ppb. So what is parts per thousand? That is the part of solute upon part of solution into 10 to the power 3. 1000 is 10 to the power 3. So in place of percentage, now we are finding in thousand. So multiply by 1000. Part per million mean part of solute upon part of solution into 10 to the power 6. Similarly, part per billion is equal to part of solute upon part of solution into 10 to the power 9. So part per million can be expressed in terms of parts per thousand into 10 to the power 3. And parts per billion is parts per million into 10 to the power 3, or parts per thousand into 10 to the power 6. So these parts per million, parts per thousand, parts per billion would be used if the part of the solute is very, very small. Traces are only present, only then we'll discuss about PPT, PPM and ppb. Now the third unit to express the concentration is mole fraction, denoted by X. Mole fraction, that is the fraction of the number of moles. So it is defined as the ratio of the number of moles of a component to the total number of mole in a solution. So if you need to find the mole fraction of solute, you can find. Mole fraction of solvent, you can find. But you should know the number of mole of that component to the total number of mole in the solution. That is X solute is equal to number of mole of solute upon total number of mole in solution. X solvent is equal to number of mole of solvent upon number of mole in solution. And solution के number of mole कैसे निकालेंगे? Solute and solvent के number of mole को sum कर देंगे, then you will get the number of mole of solution. And generally we consider the term A for solvent and B for solute. So small letter NB indicate number of mole of solute and Na indicate the number of mole of solvent. So Xa is equal to Na upon Na plus Nb and Xb is equal to Nb upon Na plus Nb, and it is always seen that the sum of mole fraction is equal to 1 because it's fraction. So when you take a part of component to the total, when you sum all the mole fraction, that should be equal to 1. So xa plus xb is always equal to 1. Now the next term, which is very important term, that is molarity, denoted by capital letter M. Molarity. It is defined as the number of mole of solute present in 1 liter of solution. Number of moles of solute in 1 liter of solution is molarity. So the unit is mole per liter and it is denoted by capital letter M. Molarity formula, you can see number of mole of solute upon volume of solution in liter. M is equal to NB upon V. Mole per liter or capital M, which means molar. So number of moles of solute upon volume. If it is in milliliter, you need to convert into liter, so you multiply by 1000. And number of moles of solute is given mass of solute upon molar mass of solute, that is WB upon MMB. So molarity M is equal to WB upon MMB into V liter or M is equal to WB upon MMB into V into 1000. And 1 molar solution means 1 mole solute is in 1 liter of solution. So 1 mole in 1 liter. Learn this formula and the definitions. Now the next term is molality. Small letter M. Molality. Here you can see the fifth letter is L and in the previous one it was R. This is molality, is defined as number of moles of solute present in 1 kilogram of solvent. The denominator is changed. In molarity, it is number of mole of solute present in 1 liter of solution. Here it is number of mole of solute in 1 kg of solvent. So solvent है और उसका mass है यहाँ पे. And it is denoted by small letter M. Molality is equal to number of mole of solute upon mass of solvent. So its unit is mole per kg or small letter M, which means molal. It can be written as NB upon WA. NB upon WA, mass of solvent, if it is in gram, to convert into kilogram will multiply by 1000. Or molality is given mass upon molar mass into mass of solvent into 1000. And 1 molar small m means 1 mole of solute in 1 kg of solvent. So this is molality. Next term is normality. It is defined as the number of gram equivalent of solute in 1 liter of solution. Here the numerator is different as compared to molarity, but here the denominator is in 1 liter solution and it is denoted by capital letter N. Normality N is number of gram equivalent of solute upon volume of solution in liter, and the unit is gram equivalent per liter or normal. Number of gram equivalent upon volume of solution into 1000. And number of gram equivalent is given mass of solute upon equivalent mass of solute, and equivalent mass is molecular mass by J, which is valency factor. It can be acidity, basicity, oxidation state, number of electron lost or gained, and this we'll discuss later. Number of normality is WB, that is mass of solute upon equivalent mass of solvent into volume of solution in liter, that is WB upon EB into 1 upon V. And you can write WB upon EB into V ml into 1000, and equivalent mass is molar mass by J. So normality is WB upon molecular mass into J into 1000 by V gram equivalent, and 1 normal is that solution in which contains 1 gram equivalent of solute in 1 liter solution. So this is normality. In normality and molarity there is a connection, there is a relation. Molarity is number of moles of solute upon in a 1 liter, so WB upon MMB into V, and normality is number of gram equivalent in 1 liter, so WB upon equivalent weight into volume. So you can see equivalent weight is molecular weight into J, so J aa gaya. Now this part is equal to molarity, so normality is molarity into J, that is valence factor. Now how do we get that valence factor and what is equivalent mass? Now we will discuss that. So equivalent mass we can find using mole concept. We can express the amount of matter, that is the mass of one atom, and correlate the mass of matter with number of entities present in it. The equivalent mass of a substance is the mass of it which reacts with 1.008 gram hydrogen or 35.5 gram of chlorine. and equivalent mass of an element is equal to atomic mass of the element upon the valency of the element. For example, equivalent mass of calcium is 40, its atomic mass. Valency of calcium is 2. So what is equivalent mass of calcium? 20. Equivalent mass of sodium is atomic mass of sodium 23 upon valency 1, so 23. Chlorine 35.5 divided by 1, 35.5. Aluminium atomic mass 27 and valency is 3, so equivalent mass is 9. So element with valency 1 is monovalent, with valency 2 bivalent, and valency 3 is trivalent. How to find the equivalent mass of an ion? Equivalent mass of an ion is formula mass of ion upon charge on ion. So Na plus has formula mass 23 and charge 1, so 23 by 1 is 23. Cl minus 35.5 divided by 1, which is 35.1. Phosphate 95 divided by charge 3 minus, so 3, so 31.67. Now equivalent mass of a salt is formula mass of salt upon total positive negative charge. That is equivalent mass of NaCl is equivalent mass of Na plus Cl minus. Equivalent mass of Na plus is 23 and that of Cl minus 35.5. So equivalent mass of NaCl is 58.5. MgCl2 equivalent mass of magnesium is 24 by 2 and that of Cl minus is 35.5. So 12 plus 35.5, that is 47.5. Now how to find the equivalent mass of an acid? To find the equivalent mass of an acid, it is molecular mass of acid divided by basicity. And what is basicity? The number of replaceable hydrogen present in acid. One mole, or it is a mole of monovalent base required to complete neutralize 1 mole of acid. For example, in HCl, how many H plus can be lost? 1. So what is a basicity? 1. So atomic mass of H 1 and that of Cl 35.5. So 36.5 divided by 1, which is 36.5. From sulfuric acid, how many H plus can be lost? 2 H plus. So 98 divided by 2. The molecular mass of sulfuric acid is 98. So 98 by 2 is 49 as the equivalent weight. HNO3 has only 1 H plus as replaceable. So 63 by 1, that is 63. And phosphoric acid has 3 H plus that can be removed. So 98 by 3. This is the structure of H3PO3. If 1 H is replaced, it is 98 by 1. If 2 H plus are replaced, 98 by 2. If all the 3 H plus are replaced, it's 98 by 3. In H3PO2, only 1 H plus is replaced. Other two are directly bonded and they are not replaceable. So molecular mass divided by 1. Now equivalent mass of a base. Equivalent mass of a base is molecular mass of base upon acidity. Base के लिए acidity term है, that is the number of OH minus ion furnished by 1 mole of alkali, or it is the number of H plus accepted by the base. So equivalent mass of NaOH is molecular mass of NaOH by 1. Equivalent mass of calcium hydroxide is molecular mass of calcium hydroxide divided by 2, because it can release 2 OH minus. Aluminum hydroxide can release 3. So molecular mass of aluminum hydroxide divided by 3. So equivalent mass. Now we'll see for a substance in a redox reaction. A redox reaction involves loss or gain of electron. So equivalent mass of oxidant, that is oxidizing agent, or reductant, which is reducing agent, is equal to the molecular mass of oxidant or reductant divided by the number of electron lost or gained by 1 molecule of oxidant or reductant. So equivalent mass of oxidant is oxidizing agent. Oxidizing agent खुद का क्या करेगा? Reduction. So it's the molecular mass of oxidant divided by the number of electron gained by it. So, or you can tell the equivalent mass of reductant is equal to the molecular mass of reductant upon the number of electron lost by it. Now for this equation, Fe2, ferrous changing to ferric by loss of 1 electron. So equivalent mass of Fe2 is equal to molecular mass of Fe2. How many electron has it lost? 1. So divide by 1. Chromium 6 plus gains 3 electron to form chromium 3 plus. So equivalent mass of chromium 6 plus is molecular mass of Cr3 plus, Cr6 plus divided by how many electron has it gained? 3. So this is how you calculate. Now Mn7 plus gains 1 electron to form Mn6 plus. So equivalent mass of Mn7 plus is molecular mass of Mn7 plus divided by 1. Now in the next equation, Mn7 plus gains 5 electron to form Mn2 plus. So equivalent mass of Mn7 plus is molecular mass of Mn7 plus divided by 5, because here how many electron is it gaining? 5. So this is the concept of equivalent mass, and the theoretical portion of the chapter is complete.